And we are live. All right, welcome back to another year of YYC Dev meetups. We have a pretty good lineup this year, so check out the meetup site for all the things that we have coming up. If this is your first time here, welcome. We usually stream on YouTube and on Twitch as well. If you've never heard of us, we are a language and framework agnostic collaborative community project. So we're just a bunch of nerds who want to talk about the things that we really enjoy, and we strive to be a welcoming environment for software developers of all skill levels. There's always an open invitation to come and speak, whether it's your first speaking engagement or if you want to do a deep technical dive into something. We're happy to share the stage with you. We have lightning talks coming up in January, and if you're interested in that, please reach out to us through Meetup or on the YYC Dev Slack. We would love to help you in any way to get on stage. If you have any questions during the talk, please put them in the chat, and we'll get to them after the presentation. And we'll just get right to it. It's really nice to have Ben with us today. I've known him for a ridiculously long time, since we were both junior devs at ThoughtWorks. I think this is back in like 2008. We've gotten a little bit older since, and now he's the VP of Development at Popcodes, building merchant support solutions for the financial industry. He's been heavily involved in the Calgary tech scene since 2010, organizing YYCRB, the Ruby meetup, for 8 years, primarily focusing these days on team building, stack scaling, and long-term product sustainability. He is a big fan of Ruby, Java, JavaScript, and beer. So I will bring him on screen, and it's all yours.
Cool. Just for the record, I haven't started drinking yet. Thanks, Serene. Hi, everyone. This is super strange. Normally, the last time I'll get into it. The last time I did one of these was April 2018. Just to show you, and of course, my dog just started barking in the background. I don't know if you can hear that. The last time I had to do one of these, the group was called YYC Ruby. And I always started off every talk with the same couple slides, public service announcement, but this time I'm comparing it to the last time I ran this. So since April of 2018, we've gone from Ruby 2.4.3 to 3.1.2. If you don't know what this means, it's fine. If you're not a Ruby or Rails user, it's fine, it's understandable. But since then, we've gone from Rails 5 to Rails 7. Which for those who use Rails on a day-to-day basis, it feels like forever, and that's the last time I had to do a public talk. So be gentle, be nice. Also, a lot has changed it seems like a lot has changed in the Calgary meetup scene. When we started this, when we started YYC Ruby, there were maybe 3 groups, maybe 4. Now there's development groups for all sorts of needs, which is great. But when I went looking for Calgary meetup development groups, I found this. So it's psychic development meetup, which is cool. Like if you're into that, it's like, wow, this is a group for everything. If you're laughing, please put it in the chat. It doesn't reinforce as well. Okay, seriously, but this is YYC Dev. So let's talk about things in a generic context. The original name when I was shopping around names for this talk, the first one I came up with, herding silicone cats, a rope of sand, which is deliberately obtuse as a name. Like a rope of sand doesn't mean anything. So I started asking people around my office, online because we're hybrid, but what they thought of the name. And the only person who didn't hate the name thought it was about crypto cats, which I don't know if any of you remember that. This is not about crypto cats or anything to do with blockchain. So if you came here wanting to know about something about blockchain mammals, you're in the wrong place. The actual name for the talk is content management and large scale distributed systems, which might be as obtuse as the herding cats title, frankly. And that's fine. We'll get into it a bit, and some strategies on how to deal with client server and distributed systems. I should mention at the top, I work for a company called Popcodes, currently hiring, growing. We're deployed all over North America and have all sorts of interesting problems to deal with. A bit about us: we write software for payment terminals, service support software mostly, but we deal with all kinds of use cases nowadays. 6 or 7 device types, depending on how you count them. Different libraries, different hardware limitations, different screen sizes, resolutions, power requirements, printing restrictions, and many different partners who each have an idea on what should be allowed in their environment. It's not as straightforward as, let's say, iOS, which it's funny to call that straightforward, but at least you only have Apple to deal with. And it's all managed by the same Rails backend app. It's a lot. So again, quick explanation. We have all of these, you can't see my hands because my screen, okay, on this, also left and right is reversed. Okay, on the left, you can see a smattering of screens that are all generated by the Rails app. They're all sort of mocked up HTML amongst other things, goes to the internet all over the place, and it syncs to a backend Rails app. And if you're asking yourself if that's a movie poster from the 1995 film The Net, you're a crafty one. You might be a dev. That's a bit about the company. Hand-wavy, but it's a content management framework for payment terminals running a multitude of OSs and in a multitude of situations. So the big question is, dealing with distributed content management, how can you reliably sync structured data and assets between disparate client systems? Like if you had to write this today, you use Couch and it's just done. Okay, that's it. Couch. Okay, that's the end. Everybody drive safe. No, it's not. It's not actually the end. That is. Couch is awesome. Our domain operates in non-standard ways. The rules, the deployment partners, the methods themselves that we originally built the software for aren't conducive to implementing something like CouchDB. It requires too much. A lot of the underlying libraries that it expects are not available. So we end up having to write our own. I hear you. CouchDB is CouchDB and its surrounding libraries are a great option, but it's not possible for us, especially not now. Okay, so what's the purpose of this talk then? A general programming structure and scenarios, things that we have encountered as a company to maybe give you some ideas in how to approach, refactor, and solve some of your own problems. So sort of the 5 topics I wanted to cover, again, broad strokes. Use unique keys, both of them. Be unique, the inherent differences between UUIDs and table level primary keys. 2, hybrid approach, cache values locally whenever possible. 3, tell, don't ask. Don't assume that remote devices are correct just because the server thinks that they are. 4, assume you're wrong. Things will eventually get out of sync. Have method to fix them while in field. And lastly, fallbacks, but more on that in a bit. Okay, so with that out of the way, let's get to point 1 and talk about public keys versus technical keys. That was not supposed to be blank. Cool. Sorry, 1 second, technical issue. I had to move from Keynote to Google Slides. and it appears as though something was missed. So give me a quick second and I will. Serene, can we get some hold music, maybe the Jeopardy theme? That'd be helpful.
Would you like me to sing? I could sing.
That is your call. Yeah, just that one slide looks like it didn't make it over because of course it didn't.
Is it like got code on it or something?
I thought that one was just text. Anyways, yeah, give me 2 seconds. I'll get something.
That's fine. Hey, it was your call. You wanted to do it remote.
I make many mistakes. I'm only human.
Heaven forbid we have to leave our house.
How many of you really want to leave your house? Yeah, why did that? It's just text. Anyways, okay, fine. We're going to do the rest. I can't see the monitor, so we're going to see how this works. Serene, can you see that? It should just say key type at the top.
Better?
Does that work?
Yeah.
Okay. I can't see the other screen anymore.
Oh. Okay.
Sorry, everybody.
Resume.
This would have been easier with in person. Okay. So when you're building a system that has any kind of data sync or a use case where some client application has heavy reliance on interacting with the server as a source of truth, you need to have some hard rules in place, like how to uniquely identify shared rep records in both systems, but they are still, remember, different systems. As such, you can't really entirely trust the client, even if you wrote the software. We'd recommend, or I would, because I can't force you to do anything, to keep your server keys separate when those are not shared with your client app. So basically the idea is that you would have a primary key, just a standard table name ID int on your server record, and on your client devices, use a secondary key, probably a UUID. So now we have two types of keys. One we'll call the table name int. We'll call that a technical key. And the universally shared one, we'll call that the business or public one. That's what we call it. Naming things is hard, so they're not the best of names, but you sort of get the idea. The technical key is the one that's used as the server, as the source of truth, and is kept to itself. It's never shared with a client device, or really to the outside world if possible. Because that's the one that we would use internally, like in the app itself. Keep it as simple as possible, just a regular auto incrementable number column, easy to remember, use, and definitely simple to find tooling for. The other is a generated one by the server or client device or by the database itself. If the client generates a new record on its own, then the client would also create its own UUID, but keep the real ID separate. Our preference for the public or business key is a UUID, but again, that's your call. Just be your own person. When I was shopping this talk around, I was asking folks, like, what do you think of the content? Like, what is a UUID? I don't understand. So quick, because I don't know the makeup of everybody who's in the talk, nor can I see the YouTube stream, so I have no idea what's happening at this point. A UUID is a universally unique identifier. It's generatable automatically by practically every language worth its salt. If you can't figure out a way to build one, maybe change the language you're dealing with. I don't know why you wouldn't be able to, but just throwing it out there. There's practically zero chance of a collision. So just brief stats that I ripped off the internet. There's a 1 in 1 billion chance of a collision in 103 trillion records. So that's pretty good. That's pretty good. The odds on you getting one are basically nil. It can happen, but no one's that lucky. If you do get a collision, go buy a lottery ticket. This is the only code you'll see tonight just how easy it is to build one in Rails, which is modern, but just as the example, you can see how long the string is. If it's a hex, if hex values are available to you, you can do the math if you wanted to figure out how many permutations there are. You're not going to see a collision. With that, the advantages of this as a solution is that you combine the best of both worlds. A UUID that you can use across reference records across both client and server, combined with a simple one to use on the server itself when you actually have to do maintenance, modifications, investigations, that type of stuff. It also, in our experience, adds an extra layer of obfuscation when communicating remotely. Never give a malicious actor an actual value to work with, or like an easy value to work with. If all they have is the UUID, that's all they're ever going to get. If they get access to the ID, it generally can work out to be a bit worse. You want to make it as hard as possible. You can cross-reference model classes with the UUID in case you lose the context of the record itself. So when you're trying to do async, if you're not using something like CouchDB or something, or PouchDB or one of the bigger ones, it is standard for you to be able to want to make modifications on a single model by just firing requests at a server. If you just have the UUID, that's enough to pull the model context, because it's only going to be creatable in one spot on the server or on the client. You're only going to, if it's created remotely, it's only going to be able to be created once. They're widely available for use in local DBs, both RDBMS and NoSQL based platforms. They're particularly used in NoSQL environments. Again, CouchDB, Mongo. I'm trying to think of another one off the top of my head. But they should be available everywhere. And if you can leverage that kind of uniqueness, I suggest that you do. 2, hybrid, which is really just a shorthand way of saying caching. Store whatever you can locally. Round trip server times, just because of better communication standards, fiber, 5G. Round trip server times are better than they've ever been, and they still suck. You really can't ever beat storing things locally if you have to pull them up in a rush, especially from a user perspective. They want to be able to see feedback as quick as possible. So having as much content on the device that the device will allow is extremely helpful, especially when you don't have to take a round trip to server, as well as the processing time on the server itself. Cache whatever you can locally. There's numerous methods for storing stuff locally now. I alluded to a few a second ago. SQLite, PouchDB, WebSQL, all available in JavaScript environments, iOS, Android. Name something else. We use something like that on non-standard bespoke devices with like an embedded JavaScript environment all the time. And there's chances are there's something available. You shouldn't have to write it from scratch. Using that in UUIDs, storing and retrieving local information, then push up the server for consumption, is the best way of doing most things. It also presents an extra problem when you have to deal with conflicts. It's kind of unavoidable in such a system. That being said, exhaustive conflict resolution strategies are a bit out of scope for this talk. It's sort of aimed at everyone. And also because how you choose to resolve a conflict is so unique to your own environment that there really isn't a one-size-fits-all solution to it. But here's a quick rundown. The inherent problem and strength of a distributed system is that you give the ability for the same data in more than one context to be revisable. But then how do you coalesce those records back into one when you sync data from client to server back down to other clients? How do you do that effectively? Okay, so simple scenarios is pretty contrived, but it shows the point. Client server, both have the same record one, and it's dog. I'm not inventive. So in both scenarios, you have a user, not the same one. I should have changed that slide. But they change one of them changes the name to Fred, and the other one changes the name to Richard. I don't know what's up with this dog, but they both want to edit the same one. So then once you have to sync the records back across the client and server, it doesn't work because how can it, right? There is a conflict there. Both of these are saying that they're true, and they both can't be. Pick who wins. That's up to you. I, as well as CouchDB, automatically pick a winner based on the last time that the record was changed. That being said, we also have excessively tight controls on what records can be edited and where, so this totally works for us. But your use case is probably different and needs to be addressed in your own way. CouchDB, for example, will pick a winner based on the edited time and store the previous record as a previous revision. It also marks that conflict's true, just so you know that if you're managing the records in the background, you can go in and change it or choose how you want to handle a conflict yourself. There's really no way around it. You have to do the work. It's not too dissimilar from a git merge conflict, where two lines are changed in two files. You really don't have a choice but to go in there and figure out which one of them is correct. Computers aren't smart. They can only tell you what doesn't make sense. Point 3, tell, don't ask, ish. Anyways, more on that. We've had scores of issues over the years where client devices will get out of sync and get into a state that we call rogue, because it's really hard to name things. The server logic would think that it had sent down the deltas for screens, so HTML screens or whatever. The server logic would say, like, we sent that information down, but the terminal would not respond with that, even though it fully accepted the response. But how? Like, we could prove with logs that the information was being sent down. We could prove that it was going through the code because certain fields would be updated, but other ones wouldn't be. So we'll get into exactly why that particular case happened in a bit, but when trying to diagnose the problem and trying to architect a way around it, I was reminded of a old school an article written by Martin Fowler, which I thought was in refactorings, which I would show you the book, but currently it's holding up my laptop just to be a bit higher. I looked at refactorings for it. I couldn't find it, so I went online and I found this. Sorry about the splash of text. That's kind of unavoidable. Tell, don't ask is a principle that helps people remember that object orientation is about bundling data with the functions that operate on that data. It reminds us that rather than asking an object for data and acting on that data, we should instead tell an object what to do. Again, Martin Fowler, I swear it was in refactorings, but it actually wasn't, at least not that I could find. It's summarized a bit later. This is a bit more concise. Tell, don't ask is a stepping stone towards co-locating behavior and data. So similar things should be in the same place, logic and data. So you shouldn't have a place where there's separate because it confuses exactly what's happening. So how this applies to the issue that I was talking about is that the client wasn't managing its own state. It was aware that it had screens. It was aware that it had data. It was aware that it had settings. What it wasn't aware of is exactly what the revision or when the last time it updated those values at. This goes for the entire configuration as well as individual screens. When you think about it, like, this wasn't very smart, and I'll admit it. There's a reason behind it. Previous versions of the client devices disallowed us from saving much data remotely. They weren't capable of it. In recent years, especially with more modern client devices, we can store a lot more. So we decided to take advantage of that and start to sync based on the epoch time of the when the terminal last thought it called in, what the server said the version was that it got. So now that we have this value on client itself, we can pass that time back and forth to the server and saying, this is what the client thinks its last time was. And this actually solved most of the problem after we thrashed on it for about a month, as to like, how do we solve this? Because it was saving in such an odd manner. The client should keep in control all the data that it needs to complete its own tasks, which includes its own communications timings and as well as its own revision information. And tell don't ask was supremely helpful. All of a sudden we were in a situation where we weren't asking the server, like, what do you think we should have? Instead, the clients are now telling the server, this is what I have. This is what I think I have. It's a lot more work to go through and parse it all out, but it's the only way to be accurate. And even then it fails in other ways because everything does. But it was, tell the don't ask was a great way to rethink our own assumptions about how our code was working in the real world. Half the data values would update, but the other half wouldn't. So you actually have to start comparing things all the time, because of other issues that I'm going to get into. Now the unfortunate part is that, oh geez, I did that. Thanks a lot. Cool. Okay, that was helpful. So, sorry, this is seriously the next paragraph in the article written by the guy who's saying helped us solve a months-long problem. But personally, I don't use tell, don't ask. I don't find it a point worth highlighting, which is great. That we found it so useful and he didn't. It was literally the next paragraph. I obviously did not remember this part of the article when I started thinking about it as part of my day-to-day refactoring life. I've always thought of it as useful when refactoring code, just because it doesn't for him. That doesn't mean you wouldn't find it a helpful way to structure your own code, especially when you're trying to refactor your own assumption about how your code is actually running. That's the point. So to reiterate, data should be housed and used in an object in context where it belongs, not stored somewhere else and then grabbed and operated on. It should all be in the same object. Don't assume that the client has a current copy of the data. Don't assume that the client has a current copy of the data, because eventually it will fail on you. More on that in the next point. Think about it in OO terms. You shouldn't just think of the housing object as being the housing physical object as being another data source. It's its own object as well. The client device can handle its own state, and it should be thought of as such. It's a separate element. It's a separate thing. It controls its own state. It shouldn't be managed by the server. Epoch time is particularly useful pretty much always when trying to figure out exactly what time it's at, as well as doing managing or trying to grab the epoch time from the device itself. We cross-reference that with time from server. So if the time on the client device is wrong, it will generally fall back to the server time, because the server time, we take great care to make sure it's always up to date. Next point. This is sort of a humility one. Assume you're wrong. Scheduling regular and unprompted check-ins with server is invaluable. Bidirectional communication, if possible. A lot of the devices that we deal with, it's not possible. Once the device has stopped calling in, you can only wait until the next time it tries to call in. But on every request and response, inform the server what client thinks it has, and compare that with what the server thinks the client has. You might lose a little bit of time just based on passing UUIDs and timestamps back and forth all the time, but it's the only way to make sure that everything gets updated as you think it should, and merge incorrect records as soon as you find them. If you let them get too far, it typically comes back to bite you down the road. Something I've alluded to, but you have to recheck old data as well. For a couple reasons. So data can become corrupted without you ever really knowing it. So I've said that we can save the revision time. So the terminal tracking what it thinks it has. So we ran into a situation where the revision time would save, but half of the underlying data objects wouldn't, because the power was getting shut off halfway through. You can't know that. You can't know when something is half saved, because everything is going to save things in a slightly different manner. And it goes like that across the board, even with relatively modern devices. If there's an unexpected power outage, a bug, an exception, something gets risen in the back, could result in unexpectedly stale data or missing or corrupted data. Happens often, and it still does, even with Android devices that we run on. Communication problems, occur often in the wild. Once you get into like a client low power mode attached to an AT&T 3G tower in some backwater town in rural America, which we run, nothing really makes sense anymore. And you start to see some truly strange behavior from client devices where they'll sync half of them. They'll sync one of them. They won't sync at all. Sometimes they'll be able to call in. Sometimes they won't, just because of communications challenges. Even nowadays, it's still a constant problem. The same old problems that people were facing in the 70s when these types of things were starting to come out. Just these type of architectures, I should say. Another point to be made is that you should be constantly syncing data around to checking for new fields. Often schema changes with what's stored remotely. If you're in a situation where you can't store everything of a record on every device, or it doesn't make sense to, but down the road you decide, no, I want to share more fields, but the revision time hasn't changed. The record on the client device still thinks of itself as being up to date, and it's really not, right? It's up to date, but it's missing a field. Those are things that if you're constantly syncing, you can reduce the odds on missing fields, especially if applications are being if application versions are being changed out without changing the database itself. I imagine I would get some questions about that because I feel like I'm doing a bad job explaining it and I can only see my own screens. So make sure you ask about it in the comments, please. 3 issues: communications cut off mid-transmission. I talked about that a bit. Incomplete data. So 3 issues that can come up from that we've encountered a bunch: communications cut off mid-transmission, incomplete data off by 1 errors, obviously, because there's 1 missing, and server provided values changing over time, again, adding or changing fields. It sort of works out to be a similar workflow to Git, where you're constantly, if you're on a feature branch or a bug branch, best course of action is to be constantly syncing with master, because that's ultimately where you want to get to. Instead of syncing with master, we're syncing with source of truth, server, whatever you want to call it, database on the other side of the world, couch, whatever you have. You should be constantly asking what is changing in order to make sure you're as up to date as possible. Last big point, fallbacks. Whenever possible, give yourself some methods for getting rogue client devices back into line. That can go, when I say client devices, it could be, in our case, payment terminals, it could be Android cell phones, it could be iOS devices, it could be web front ends, because client-side model view controllers frameworks are as popular as they've ever been. They count as a client server, in my opinion, nowadays. There's no way around it. They are their own. That is their own app. Schedule call-ins for data sync and verification, regardless if you think something has changed or not. Syncing every hour, 2 hours. With our application, it's actually configurable, depending on exactly how often you think the client will be changing content, and that's the call-in frequency that you actually that we set. For our biggest client, it's set to every 4 hours, and sometimes that's not even fast enough because they want to change the screen out in real time if they have an outage. If there's something that they need the client to, that they need the end user to know immediately. Payment gateway down. You know, you could come up with any number of reasons of explanations exactly what some of these cases could be. But just make sure that you're constantly calling in over on some regular time frame to check to make sure has anything changed. I should have been on this screen. Allow loading. Sorry, that was stay in touch. Allow loading offline content that doesn't require a persistent internet connection. Again, this is sort of the advantage of server of client-side applications. Your offline web apps, JavaScript running in the background, but no internet connection, but it can continue to function until such a time as they can make a connection. It's also worth bringing up the idea of loading every application that you have with some sort of default offline content that doesn't require an internet connection that is always there, and dealing well with the fact that you might not have an internet connection at all time, or the server might be down, but it gives you something to read off of from default that's loaded onto a device that you actually can depend on always being there. Doesn't really matter what it is, pre-formatted database file, JSON file, YAML file, take your pick. It doesn't really matter what it is. It can run off a file. But you have to make sure that if the device runs, it has to be able to run even if there isn't a persistent connection. The last point is a bit inside baseball for us. Allow devices to call in on a whim if they're missing data. You should be able to rig up something that if your application it feels as though it's missing a piece of data, or it wasn't synced correctly, or it's going way outside the known realm of what you thought that application could ever be asking for. It should be able to call server and get that information down in a reasonable and normal request response loop. Don't depend that if it's not in the database itself that you shouldn't be able to have access to it. For instance, you can imagine a scenario where you have a high volume transaction device and you're storing payment transaction universal IDs locally and the only UID. And you can only store a few of them because of space restrictions on that device. But for some reason, the user wants to print a receipt from 2 days ago. The nerve. Well, that's something you should be able to reach out to the server and request. Just because we have all this fancy stuff where you can store things locally, the same problems are always there, and they always have been. Where what do you do when you need information that you otherwise don't have access to? You still have to be able to go and grab it. No matter what this situation is, users don't typically do well if you say like, no, we don't have that information for you, but they know they should have access to it. If you're going to open up that device to be able to do a whole host of things, depending on your contact, again, it depends on exactly what your domain is. You can't say just because it's not in the local database, you can't have access to it and just have the database manage itself. You still have to be able to go out and get the remote request if necessary. And there's really never going to be a way around that. But that's really all I've got tonight's tips, tricks, things that I've learned over the last few years dealing in this kind of niche environment. Wait, did that work? Okay, yeah. I think, what? Okay, so tonight we talked a little bit about security caching architecture and refactoring strategy, and a way to think about OO that I've always found very helpful. It seems simple, like, well, similar things go into the same place. It's something that quickly loses sight when you get into sort of a long development cycle to go back and think about those very basic problems. Some strategies around data sync, and that you should be thinking about how to deal with scenarios that aren't part of a normal use case. They still have to be thought of, and they're still very much part of your product, even if you can't get an immediate answer. People don't really deal with that well. Contact information. This is how you can reach me if you're looking to change up your current gig. We need help. I don't know how else to say that. The other one is my Twitter, which I don't really use for anything except for lurking news. I've long since nuked all my own tweets. And I'm gonna get rid of it here soon, I think, just based on the way things are going. But I felt like I had to write something down for a secondary proof of life, if you will. So for the time being, if the account is active, please contact me. We can chat, have a coffee, see what's going on with other devs in town. It's good to be back out. I'm going to end just questions now, but I have to close the window in order for anything to be visible. So what a mess. Just do it in Google.
Remote. I gave you the
slides.
choice.
Everybody, if you ever have to do a talk, just do it in slides. It's fine.
I gave you the option of like doing it in person.
Oh, I'm sure I would have had a problem there too. This is not just something else. Like
it's been a while. We haven't done one in a while.
Car crash outside.
I have a couple questions, but
okay.
There's one there.
Storage preferred local. What are the pros and cons of that? Storage preferred local. Like, are you talking about like what are the advantages of storing local? Like, it's a separate database to manage, right? So partially what I alluded to, it's a separate system requirement. It's another thing to manage. If you're in a small team, it's the complication of having to deal with caching and merging and data freshness, and it's a massive amount of overhead onto what's already not easy. Development, development is inherently hard. If once you start to complicate things, you either have to be willing to put in the time for it or have a team big enough to be able to deal with it effectively. What happens, like my last point, what happens if a record isn't there? You're like, oh, sorry, it's just not there. Like, oh, no, I don't want it. That's not a reasonable answer. Just because your storage either scheme or restrictions or requirements aren't good enough to what somebody else expects isn't a reason why it shouldn't work. But that's the risk you make when you start to do this distributed systems like this. Your modern browser is an amazing thing, but it's gotten to a point, well, you can say this happened 10 years ago, that a browser is just a client device itself. I saw Ian might be here somewhere, and like he's gonna be like, yeah, of course it is. It's its own device, and he's right. That's what it is. You have to build. So then now you're not building one app. You're building 2 or 3 or 9. It's an explosion in the amount of things that you have to be an expert in, which is annoying, especially if you're in a small team or on a startup, or like, okay, we can only target 2 things, not all of them. It's better to have it local because you don't have to do a round trip to server, but it comes with an entire host of other problems. Wait, Cliff, I hope that answers your question. You can put it in the chat if it does, please.
Yeah, I think remote speaking engagements definitely come with their challenges.
Yeah, I mean, I guess I could pull up the YouTube stream here, but then
I have it like in another window muted. It's like a whole thing. I have like my dual monitor thing going.
Clamoring over there.
Well, I think it's just interesting because it feels like a significant amount of overhead to add, and I've always just worked in like web stuff where we never had to worry about that kind of syncing. And
that's the thing that's become even more apparent as the JavaScript kids, call them kids. I'm so old. Like I made a joke about the 1995 film The Net. Like I've been doing this for a while.
Yes,
it's a browser is its own client now. You can guard against it as much as you want. You have to deal with doing a lot of that stuff remotely now. If your JavaScript libraries is your client, like that is your client device. It's not just for moving things around minorly. Like no, offline storage in browser is almost a necessity now. And I don't think we're going to get past it, right? Like the Pandora's box is open. There's no way to do round trip request every request now and have it be usable by a modern person. Like it's not what they expect.
Yeah.
So you have to get.
It's basically a separate client.
It totally is. There's no way to not think about it as such.
Yeah. So it's like I'm
sure somebody in the comments is just screaming at me like, "No, you're wrong. You can get her around it." I don't know if you can.
Well, I mean, I don't know. I think it's interesting because we went to like separate client apps, and then now we're talking about server-side rendering again, and I feel like we're just going full circle.
You can fake it. It's not like make it smaller, hide it in enough ways, but it's almost unavoidable now to have to do some kind of local storage. And the tools are there. I was surprised when we first got some of the more advanced stuff in our client app up and running. We started finding all of these tools like, oh, this is really cool. Couldn't use any of them because of the weirdness of the environment that we deal in. Like we can't, our most deployed application runs in like a modified Chromium browser, and it just doesn't have the tool set that we need to run any of the cool stuff. Like, oh, geez, this sucks.
What's the cool stuff?
I God, I'm gonna forget. It's not IndexedDB, it's WebSQL, and only one of them worked. And whichever the crappier one was, that's the one that worked.
Okay, so there are ways to. That was my question. Was like, are there libraries that would help to solve these problems without having to reinvent it from scratch?
There's some great ones, honestly. PouchDB, I was surprised at how well it was when we looked at it a few years ago. It's not new either. It came out in 2013, I think was their first release.
CouchDB?
PouchDB.
Oh, PouchDB.
PouchDB is separate. It's the JavaScript implementation of it.
CouchDB always reminds me of the RubyConf scandal thing that happened back.
We'll
talk about it offline. I'll have to talk about that later. PouchDB.
Nothing tawdry on the streams, right?
So so this does like some auto syncing thing with the back end, or
auto syncing thing. Yeah, it's I'm not sure if it's part of the default like Apache project now or not. I just opened up the chat. Oh yes, thanks. Okay, cool, Cliff. Yeah, thanks. There's now what was I saying? Please remind me.
PouchDB.
PouchDB.
Other tooling that would.
Yeah, I'm not sure if it's like an official part of the Couch tool chain or not. It should be, because it says that we sync with Couch. And that being said, like even I said it a lot, like, oh, Couch is the answer. Like, Couch is a nightmare to learn if you're only used to RDBMS. It's its own monster. It's massive. So it's like you have to deal with all of your regular dev stuff, and Couch, and Pouch, and the elements on the client device itself. You want to do all of those things all at once, and you have to know them all and have them all work. Right? It's expensive.
Like it sounds really inaccessible to startup founders, honestly.
It is, and that's a big part of what, like, it at this point it's kind of a cool toy. And if you were to write, if we had the budget to do it, if we had like infinite money, and we could get rid of a lot of the syncing problems we have, because they're the exact same ones that Couch was designed to deal with. I don't know, flip a coin if I would actually explore that or not. Because we've come so far. The problems that we have are solved by Couch, but we also solve them in a way that's more amenable to our domain, right? Which is, we are not the primary device. We are not the primary reason to have these devices. We are tangential to it. So everything that we do, we have to be able to do it in less time and outside of a user scope. If you use the default Couch tools to deal with syncing and merging and all this other abject insanity, it causes a lot of overhead on the resource requirements of the devices themselves. So like, you run the CPU really bad, the battery gets worn down, and it's a bit insidey, but a lot of payment terminals on 3G and LTE networks are on shared data pools. So they get really pissed off if you start doing like megs and megs back and forth amongst tens of thousands of terminals, all doing the exact same merges all the time. Mm-hmm. So we had to be a bit smarter on exactly when we did merges and how. It's a domain specific thing, but Couch is the best tool if you have no other foothold in the problem set.
Oh, that's pretty neat.
It actually is really cool.
It's like some pretty big nerd topics.
Yeah, I could keep going for a long time, but that's why the talk was meant for everybody.
No, that's good. I think that gives a really good intro into the challenges that exist in data syncing with distributed systems, and it gives people somewhere to kind of go from. So, will you be okay with us posting your slides in the meetup group?
Yeah, I'll dig it.
Or you can post it.
I'll strip the.
Yeah, you can clean it and post it on the meetup group. And there's nothing else. I will close off.
No, that's good.
All right.
There's only 3 of us in here, and I'm assuming I'm one of them and you're one of them, and I don't know.
Well,
No idea who
we
the
have
third
some
one is.
people on Twitch as well.
Oh no, Twitch is a thing. Oh god, so many.
Yeah. I streamed to a couple because it's a little bit more accessible to different people. And some people watch after as well. If you guys have any questions, please leave questions on the meetup group and share the recording with your friends. And we will see you guys next month.
Thanks, everyone.